Okay, okay, that's fine. Yeah, I think yeah, everybody is there, I guess.
Okay, so we'll start the session.
Yeah.
So what is, could everyone please mute yourself? Can you please mute yourself? I guess Microsoft has not muted themselves. Banu, please mute yourself.
Sorry?
Please mute yourself. Please mute yourself.
Okay.
Thanks. Okay, so let us start the. If you have any questions, you can unmute yourself and ask me. You can stop me anytime you want. I'll answer your questions. But please mute yourself. I think someone has not still muted themselves. They still hear some disturbance. Banu, I think you have not muted yourself yet. Thank you. So let us start with the demo. So what is SAP HANA? Okay. So there are basically three important words in HANA. One is high performance, analysis, appliance. So what do we mean by high performance, analytic and appliance? Okay, high performance, for example, let us say that you are traveling from location A to location B. There are several ways that you can travel. You can travel by train, you can travel by flight. Let us say location A would be Chennai and location B would be Delhi. So there are several ways that you can travel between them. So you can travel by walk, you can travel by flight. So probably if you travel by flight, it would take only 4 hours. If you travel by train, it would take only 2 days. If you travel by walk, it would take maybe 50 days. But if you ask me what is high performance, obviously I will say flight is the high performance because the distance being constant, between A and B, and then you would like to travel, the less time taken is by flight. The same way, how do I
Yeah.
compare?
Hello. I mean, your voice is breaking. There was a lot of echo.
Lot of echo, is it?
Mm-hmm. We were not able to hear actually. After like I think I missed almost like 2 minutes conversation, I guess.
But we are able to hear very clearly.
Yeah. Now it's fine.
Okay. Probably what you can do is if you have any applications which are running in the background which consume internet, for example, any downloads, you kindly please stop for until the demo session or until the class session. After that, it should be fine. So sometimes it takes the
Okay.
bandwidth. Okay. Thank you.
Yeah.
So basically, what I was actually trying to say is, I'll just try to repeat the same thing. So whenever you want to travel from one location to other location, there are different ways that you can travel. But we choose flight because it is very fast to travel the same distance. So the same way, when I want to compare this example with HANA, let's take a table, and then in this table you have around 100 billion records. 100 billion records you have in this table. Or some tables you have around 1.5 trillion records. Let's say, take an example of Walmart. Every day, the transaction volume of Walmart is around 3.5 million. So, for a year, they generate around 1.5 trillion records. Now, in a 1.5 trillion records, you want to analyze data and then you want to know simple, like simple question you're trying to ask. Okay, get me my top 5 products, or get me top 5 customers. So whenever you try to ask this question, now you're trying to do some kind of analysis. Analysis is nothing but asking questions to the database. Now when you're asking questions for this kind of volume of data, first it has to scan the entire table, it has to scan, aggregate, and finally it has to give the result, right? Now if the same table resides on MS SQL, if this kind of volume of table resides on MS SQL, to generate this kind of report, it takes more than 5 hours. Even for Oracle, IBM, DB2, any RDBMS which is disk based. Now for the same data in HANA, when you try to generate a report, it takes only 2 to 3 seconds. So it takes here 5 hours to generate the same report that you generated previously. Now in HANA it takes only 2 to 3 seconds. Now why is that HANA is so high performance when you compare with MS SQL which takes 5 hours? What are the reasons behind it? So let us try to analyze the reasons behind it. So these are the following reasons. First reason is HANA is a in-memory database. It's an in-memory DB. Second reason is it's a column-oriented DB. And third reason is it's a massive parallel processing. So let us try to analyze each one of them in a detailed fashion. So let us first talk about in-memory databases. What are in-memory databases? If you see a computer architecture, in computer you have 3 main components. One is CPU. CPU is one. The second one is RAM. The third one is disk. Generally, the databases like MS SQL, Oracle, IBM DB2, all of them store data on disk. But HANA directly stores data in memory. So in-memory databases store data in RAM, and HANA stores data in RAM. Whereas other databases store data in disk like MS SQL. The table is over here. The 1.5 trillion records is over here, and 1.5 trillion records is over here. Now when you store the same table in a container called RAM, it is faster. Now actually what we are trying to do is we are trying to separate the content from the container. So we are trying to separate the content from the container called disk, which basically stores data on an iron plate. We are trying to separate the content and keep it on memory. Memory is made up of transistors and capacitors. So we are trying to store the same. Could you please mute yourself? Someone has unmute. Devender, please mute yourself kindly. So we are trying to separate the content from the container and keep the same content in a different container called memory, and suddenly it is faster. How faster? It is 100 to 1000 times faster. It is 100 to 1000 times faster processing of data that used to be on disk. So suddenly when you change the container, it is faster. So why in-memory databases are faster is because memory processing of data in memory is faster. That is one reason. And the second reason is whenever you keep data close to the CPU, it is faster. Whenever you try to store data close to the CPU, it is faster. Now tell me something, is it better to drink water from kitchen or take a flight, go to Delhi, drink water, come back with the same flight? Better. Always drinking water from kitchen is better because it is nearer to us. It is something like getting data from memory is very, very faster than RAM requesting disk. Disk has to give back to the memory and to the CPU and to the front end. So in-memory database are faster because of two reasons. One is memory is faster. So when you keep data on memory, it is faster. The second reason is whenever you keep data close to the CPU, it is faster because it doesn't have to get from disk load to the memory and to the CPU. Coming to the second point, what are column-oriented DB? There are two kinds of databases. One are called as row-oriented DBs. The second ones are called as column-oriented DBs. Let us take a simple example over here. Let's say I'm trying to generate a report for customers. Who are the customers? What are the products they are purchasing? What is the quantity and what is the amount? So this is a row-oriented table. So 001, product is P1, amount is 10, quantity is 100. So this one is a row-oriented DB and here is a column-oriented DB. So why are column-oriented DBs are faster than row-oriented in processing of data? Let us try to analyze this. So whenever you're trying to ask a question again, so let us say you're asking a question like who are my top 10 customers? So the query, the SQL query file will go to the table and we know 002 is the top one customer because the amount is 200. We're seeing based on revenue or amount. So first it has to go to the first record, it has to scan the first record and then it has to scan the second record, third record, fourth record and then finally give the output. It has to, so what I'm trying to say, irrelevant of the query, it has to scan the entire table over here. It has to scan the entire table. But in a column-oriented DB, let's say you're asking who are my top 10 customers. So it hit the customer column, it will hit the amount column. It will skip product column and amount column. So here you have only 4 columns. But if you take in real time or in real example, probably you may have columns around 100, 200, 400 sometimes. Tables are as big as 400 columns. Now when you're asking a very, very simple question, probably the questions that are made up of 3 columns, 4 columns or 5 columns, probably. In a row-oriented, it has to scan entire 200 columns to answer a question, but in a column-oriented, it only scans those 4 columns to get the answer. Why column-oriented DBs are faster is because they only scan the required columns requested by the user. In a row-oriented, it has to scan the entire table and give the output. So that's why column-oriented DBs are faster than row-oriented. And the way they store the data is little different than column-oriented. So they store data in a column-wise. So same table is stored something like this internally. This is one column, right? In this column, it has customer. So when you ask a question what it does, it goes to the customer column and then it goes to the amount column. It skips quantity column and it skips the product column. But here, if it has to reach amount, then it has to pass quantity. It has to pass product. It cannot go like this directly. It has to go row by row. It has to go in a row fashion. If it has to go to 100, then it has to pass P1 and 10. But here, it goes to the C1 directly, it skips this column, it skips and goes to the amount column. That's why column-oriented DBs are high performance. The reason being, they do not have to scan the entire table, they only scan the required columns requested by the user. That's why column-oriented DBs are high performance. So the first reason that we are trying to see was why in-memory DBs are faster is because they store data on memory. And whenever you keep data close to the CPU, it is faster in processing. That's why in-memory DBs are high performance. The second reason is whenever you store data in column-oriented fashion, they don't require to scan the entire table. They only scan the required columns requested by the user. Let us come to the third part of it. What is massive parallel processing? So let's take a very simple example, a very layman example. You have a building and the building is a 10-story building. The building is a 10-story building. And then you are asked one person to paint the entire building. You ask one person to paint the entire building. So what this guy has to do is, first it has to go to the first floor, paint this, second floor, paint, third, paint. So what he is doing here is, he is doing sequential processing. So it has to paint, go to the second, third, fourth, fifth, sixth, seventh, eighth. So here the resource consumption is very less, but time taken is also more because it has to sequentially paint all the floor one by one. But let us take another example. Now you have four persons. Person 1, 2, 3, 4. So each person allocates works to him. So first person paints the first floor, second one does second, third to third, and fourth to fourth. So here we are talking about massive parallel processing. So parallel processing of data. Now let us assume that again instead of building, this one is a table. And then you have around 10 billion records. So each 10 floors we take this one as 1 billion records, second billion record, third billion records. Now this one we consider them as processors or CPU. Each one is a CPU. Instead of person we take it as a CPU. Now if you have a single core processor, it has to process data sequentially. If you have multi-core architecture CPUs, each CPU in HANA can scan 3.5 billion records per second per core and can aggregate 15 million aggregations per second per core. They can aggregate 15 million aggregations per second per core. So in HANA, one core can scan 3.5 billion records and aggregate 15 million aggregations per second per core. So if you increase the number of cores, then the data processing is completed faster. If you have one core and then 10 billion records, then it will obviously take 3 seconds. If you have 3 cores and then 10 billion records, it will take around 2.5 seconds. So if you increase the power of the CPU, the larger volume of tables are broken down into smaller subsets. Each subset is individually processed by each core, finally assembles the result and gives back to the user. So in HANA what it does is, whenever you have large volume of tables like 100 billion records, 1 trillion record, what HANA does is, it breaks down the table into smaller pieces, and each part is assigned to the CPU. And each CPU processes the data individually, finally combine the result, gives back to the user. So the impact of massive parallel processing is it takes less time to process large volume of data by using the multi-core architecture of a CPU, where you have 4 cores, quad-core CPU, 8-core CPU. In HANA, typically you find 8 core, 16 core, 32, 64, 128 cores of CPU inside each node to process the data. So it has a very powerful hardware. So we started with asking one question: why is it MS SQL takes 5 hours to process the 1.5 trillion records of data and HANA takes only 2 to 3 seconds? The reason being, HANA is an in-memory DB, column-oriented parallel processing. In-memory DBs process data faster because they store data on memory. Column-oriented, they don't have to scan the entire table. They only scan the required columns, so it is faster. In massive parallel processing of data, large volume of tables are broken down into small pieces. Each part is individually processed. Finally assemble the result and use back to the user. The speed it can process the data is 3.5 billion records per second per core and 15 million aggregations per second per core. So this was what HANA does, but HANA does everything internally. As a consultant, we don't have to involve in any of the activity. Everything is done programmatically. Everything is done inside HANA. We don't have to do anything. But what is our role in the project? What is our role in the HANA project is we are called as SAP HANA application consultants. We are called as SAP HANA application consultant. So what is the role of SAP HANA application consultant is, there are 3 important tasks that we have to do. One is called data modeling, modeling of data. The second one is called as data provisioning or data extraction. Our third one is called as data reporting. So these are the 3 things that we will be involved in a project. One is called data modeling, data reporting, and data provisioning. So if you see a typical HANA landscape, you see the landscape of HANA. If you see the HANA landscape, so you have the source system, and you have data provisioning, and you have the target system. And there are 3 important tools in data provisioning. One is called SLT, System Landscape Transformation, BODS, Business Objects Data Services, and DXC, Direct Extractor Connection. So typically if you see in SAP landscape, so this is where your ECC or the OLTP system, online transaction processing systems. And here you have non-SAP databases like Oracle, MS SQL, IBM DB2, all these are databases. Now, if we see the opposite of what we saw here, in-memory databases versus disk-based databases, column-oriented versus row-oriented. massive parallel processing versus sequential processing. ABAP does sequential processing of data. So disk is slower than in-memory, row is slow, then column-oriented, sequential is slower than parallel processing of data. So the data that you store on the ECC side or on the above application layer on the database MS SQL. So because you are using the application layer on the database called MS SQL, obviously MS SQL is a disk based, it's row oriented, and as you know about the sequential processing of data. So why we would like to move data from this application or database via data provisioning to HANA? Why do you want to move it? So you copy the tables, for example VBAK, KNA1, MARA, these are all the standard ABAP tables provided by SAP. So we move all these tables from ECC via SLT. SLT stands for System Landscape Transformation. So we transfer the data from here and put another copy of data in HANA. This is called a sidecar scenario, sidecar approach, wherein you transfer the data via data provisioning tools to HANA, and now the tables in memory, column oriented, parallel processing. So the tables over here are very faster in processing the data than the same tables which are here, because these tables are column oriented, in memory and parallel processing. So we take help of these data provisioning tools to transfer the data from source system to the target system, because to utilize the advantage of HANA. So SLT to move data in real time, it's real time move data from source to target, whereas BODS in batch processing, batch scheduled process. So daily at 8 AM schedule the job to transfer the data to HANA. Now why do you want to use batch processing? Because not all applications in SAP needs real time. For example, inventory management needs real time to transfer the data from source to target, because you want to do stock analysis on the shop floor. But let us take an example of HR, payroll processing. Now why do you want to transfer the payroll data real time? Because payroll is only generated once a month. So for those applications we don't need real time transfer of data, because data is not going to change on a daily basis or an hourly basis. So whenever you have a requirement of data being changed in real time, so for every minute or for every hour data being changes, then you can opt for SLT. You can go for BODS when data is not being changed so frequently, probably once a day, a week or a month or a year. They can go for batch processing of data, scheduled process. So real-time transfer of data use SLT, batch processing of data use BODS. And DXC is used to transfer data from ECC. In ECC you have something called data sources of data, and these are nothing but function modules, and these function modules are the standard function modules provided by SAP, and they deliver them as a part of BA content, and this BA content is used for, especially for BW, business warehouse, and these are called as extractors to transfer the data to BW. But now we use the same extractors that are being used for BW to transfer the data to HANA via a service called, it's not a tool but it's a service called as DXC. The full form of DXC is direct extractor connection. So direct extractor connection is used to transfer data from ECC, inside ECC from data sources. These are actually utilized for BW purpose we can transfer the data via DXC to HANA. And from HANA, we can do business intelligence, BOBI reporting. Alright, so data provisioning is a tool. Data provisioning is a tool where we transfer the data from source systems to the target systems. Either it could be a real-time transfer of data or a batch processing or via DXC to transfer data from data sources to HANA and then generate BOBI reports, business objects, business intelligence reports. So in data reporting, we directly do it on BOBI. Data provisioning, we use SLT, BODS and DXC, and data modeling, we directly do it at the HANA. So these are the roles of the SAP HANA application consultant. But let me show you on system about all these various tools. So you will be given, I think Equipsoft has been discussed with you. So you will be given 3 months of access for all the landscape that we have with the integrated server. Okay. So let me show you the landscape that we have. So we go to, here we have the HANA Studio. So here you see the BODS, Business Data, SAP Data Services. The UI is Data Services Workbench. Workbench is the UI, and HANA Studio is the UI for HANA. So here you have the HANA Studio, which is the UI, user interface. So in order to log into the database, so first what we do is we add instance. So add system, HANA server, instance is 07. So we are connecting to the HANA database. It's something like how you add your SAP application server in the SAP GUI. The same way I'm trying to add a system in the HANA. So now we give the username and password and click on finish. So once you click on finish, now you have the instance added. Now here primarily there are two things. One is called catalog and content. We would see in detail. Before that, so this is one UI. So this is the target system, which is the UI here is the HANA Studio. And for BODS we have Data Services Workbench. BODS Workbench is the UI. The navigation would be go to Start, All Programs. Data Services 4.2 is the version that we are using, and HANA SP8, which is the latest version. So this is the UI for BODS, and then you have ECC as your source system. ECC version is 6.0, and then you have MS SQL, SQL Server Management Studio, So this is for non-SAP replication, and here you have SAP BODS, and SLT is directly embedded into the HANA Studio, where you have something called data provisioning over here. If you click on data provisioning, here you can see the SLT. And DX is a service which is in ECC. If you go to SM59, there is a HTTP connection created to the external systems DXC HANA. So this is basically a configuration. So this is DXC configuration. So whenever you replicate tables into HANA, by any of the data provisioning, let me show you. If you go to the catalog at the HANA Studio, we expand the catalog. Catalog is a collection of schema. If you expand the schema, here we have tables, expand tables. The schema is a collection of tables. Let me go to any of the table like VBAK. Double click on VBAK. Now please see, VBAK is a column store. It's a column oriented DB. HANA also is a column oriented DB. So we can create tables either in row or in column. Let's say you're trying to create a table. So either you can create table in column store or a row store. Generally all the tables are in row, but in HANA all the business data by default store in column stores. The advantage of column stores are read access is very faster than row stores. Whenever you try to request only few columns. So when you double click on VBAK, if you click on runtime information, here you would see the total memory consumption for VBAK is 4.2 MB of data. Column stores basically have, to see column stores at the HANA Studio, they basically have two parts. One is called delta area and the other one is called as main area. So whenever we try to insert data, first it goes to the delta area and then there is an asynchronous job which runs on the background which transfers the data from delta to main. The reason being, let me show you the reason being. See, if you see the table, you have two parts. One is called delta, the other one is main. In delta you have around 4.2 KB or 4.2 MB of data. In main store it is still empty. So to move data from delta to main, we do something called delta merge. Right click on the table and we perform something called delta merge. So what does delta merge do is, it moves data from delta to main, but the data is compressed format. So there is a 4x compression. Let's say you have 4 GB. Now you want to fit the 4 GB of data into 1 GB of data. We do compression of data. I'll tell you in detail what compression does it. But before that, let us see if you perform delta merge. Click on OK. Now if you click on refresh, now how much it takes to store on memory? It takes only 0.5, so approximately 1 MB of data. So previously it was 4 MB, now it is compressed to 1 MB. It means that whenever you do compression, you require less memory to store data. Less memory means less money. You require less money to store data. So because memory is expensive, what SAP has done is, you can compress the data from delta storage to main storage. So whenever you try to insert data, first it goes to the delta area and then system automatically performs this merging activity, which is called delta merge, and then it moves to the main store and data is compressed. Now you can see all the compression statistics. If you go to the instance, double click on the instance, go to system information, and here you see merge statistics. If you double click on the merge statistics, here you would see, now for the table VBAK we have done a hard merge, but system automatically does auto merge. So it checks whether any records have been inserted into the delta area. It moves data from delta to main where data is compressed. So whenever the data is compressed, it is very fast in loading to the CPU. So what does internally happen is, let us take a small example. Let us take an example of Aadhaar card. In an Aadhaar card, you have UID, unique identification number. So every citizen of India, you know, there is a column called gender. In gender column, you would indicate for every row in the table whether he is a male or a female. Now each alphabet or each string occupies around 1 byte of data. 1 byte means 8 bits of data. Now let me maintain a lookup table saying that internally what system does, it maintains a lookup table saying that, okay, male is equal to 1, male is equal to 1, and female equal to 2. So what system does is, so instead of storing male, now male means it has to have how many bytes it has to occupy? 1, 2, 3, 4. So 4 into 8, 32 bits of data. So male will typically occupy 32 bits of space in memory, nothing but 4 bytes of data. So now an integer which is 1 will occupy only 1 bit. Only 1 bit. So when we say now 1 bit, now we are converting data from bytes to bits. So this is nothing but compression. So instead of taking 4 bytes of data, now it only takes 1 bit. So instead of male, it only stores male one time, but whenever it sees male, it only says, okay, next record is 1, 1, 1, 2, 2. So now 1 into 3, because 3 times the male has been repeated, 1 into 3. So in this way, it will identify each row uniquely, and based on that, instead of storing the actual integers, instead of storing the actual strings, it converts to integers. This is called as decoding of data. It does decode the data. So decoding is nothing but converting from strings to integers. But if you show the same data which is in the form of integers to the user may not understand, because we are showing user ones and twos, he may not understand. So again it has to encode the data. Again it has to encode the data by using a special algorithm called run length encoding. Now these algorithms are executed inside the cache memory of the CPU. Inside the cache memory of the CPU, these algorithms executed. Again inside the cache memory of the CPU you have 3 cache memories. One is called L1 cache, L2 cache and L3 cache, where L3 cache is not so expensive but very much high performance when you compare with RAM. So if you see the performance wise, L1 cache is the highest, having the highest performance, L2, L3, and then RAM, and then SSD, solid state drive, and then disk. So what actually I'm trying to say is, so if you have a multi-core CPU, so when you store, you take less space. When you take less space, you require less hardware. When you require less hardware, you require less money. At the same time, we show the same data again back to the user by encoding the data, converting strings to integers in the L3 cache memory, which is very fast in processing the data, and show the same data back to the user. So in a table you have two areas in a column store. One is called delta and the other one is called main. So when you insert data, it goes to the delta storage. So inserting of updating of data, insert and update of data directly takes on the delta area, and when you move the data from delta to main, it does all these activities which I'm trying to show you now. It decodes the data and puts it into the main memory, which is very optimized for read performance of data, reads of data. So why it is optimized for reads of data is compressed. So when you have a compressed data, it can load faster to the CPU. If it can load faster to the CPU, again there are special algorithms which are executed at the CPU level, which is called as run length encoding, which is executing inside the L3 cache memory of the CPU. L3 cache memory is very faster than processing data on RAM, and finally shows back to the user. So data is inserted update to the delta area, moved to the main area by doing an activity called delta merge, which is asynchronously performed by system. Once the data is moved to the main area, now when a user reads the data, it reads from the main area, but let us say the job is not executed and the data is still residing on the delta area, and now user is executing a query here. In such a scenario, the data is requested from both the areas. But only thing that user finds is, user can find a little delay in reporting. A little delay in reporting, but he can access both delta as well as main area. So now if you see, if we go back again to the VBAK, we double click on this. Now here you have the main store and delta store. So when I'm reading the data now from open content, now you can see all the data of the VBAK. If new records are coming to the delta store, even then I can access the data. So today I was actually trying to give you a brief introduction about what is HANA, why HANA is a high performance appliance, and what is the role as a SAP HANA consultant that you would perform, called data modeling, data reporting, and data provisioning. And still haven't discussed about anything about data modeling, but as a part of data modeling, we create attribute views, analytical views, calculation views, authorization. You want to have analytic privileges, procedures to push down the logic to the database, and then data provisioning is how you want to move data, and transporting of objects from one system to the other system. So we create models in the content. Content is a collection of packages, and packages are a collection of the information views. So all these kind of views that we create. Analytical views are a star schema models that we use to generate reports on top of them. And then we use something called BOBI, Business Objects Business Intelligence. So we have several tools in business objects like analysis for office, analysis for OLAP, Explorer, Design Studio, Crystal Reports Enterprise, Crystal Reports, Lumira. So these are all the presentation. How you want to present data is what BO will take care. So we have different tools over here. So this is BOBI. So data modeling is done at the native HANA. Data provisioning is how you want to move data from these systems to HANA, and finally the presentation of data in data reporting. So we would see all this in very detailed fashion, and then coming to the course curriculum that we have over here. So first, because anyway I think most of you are from SAP background, sometimes people are not coming from SAP background, I would give the SAP introduction, and then introduction to HANA. So we see the architecture in HANA, overview, HANA licensing, how licensing is done in HANA. What are the different things as a HANA application consultant that you do in HANA Studio? What is catalog, content, packages, different kinds of join, how to create hierarchies, data foundation, calculation view, defining of star schemas, how to move data via BODS, business objects data services, implementation scenarios, how to do data provisioning using SLT, system landscape transformation. So these are all the various topics. Even though I try to tell, probably you may not digest now, but later point of time we will see in detail. So DXC, direct extractor connection, is how you want to move data from data sources to HANA, and reporting, presentation of data, authorization, how you want to control the data access, transport, lifecycle management, different kinds of privileges, and finally we'll discuss with the interview questions and certification guidance. So I've trained more than 500 people in this area. So most of them have cleared SAP HANA consultant HANA certification. So if you're looking for certification, then obviously it will add value, and even after going to job, certification is very valuable because I think most of them nowadays SAP prerequisite for HANA is to get certified in HANA, especially if you are in US or in UK or any other country. But in India, as you know, we don't get opportunity to write certification over here as easily as in other countries, because here we have a process. Only people who are working only can write certification. Generally, people in India write in TECET, technical education. But in India, if you want to write certification, we need to enroll to a SAP education course, and that is very, very expensive. So people who are generally in outside India, they can utilize the advantage of writing the HANA certification. And obviously, certainly it will add value to your resume. Any other questions? Banu, Devender, Pradeep? Any questions? Please go ahead. Always you can stop me while taking the class. You want to ask any question, you don't understand anything, always stop me and ask.
Hi, this is Banu. I joined little late. I forgot your name. What's your name?
My name is Nagarjuna.
Hi, Nagarjuna. Sorry for that. You told me that most of the data it is going to store. It means it's never stored in the CPU.
It never stores on the CPU, but CPU is basically used to process the data.
It means in SAP HANA it's always stored in the RAM. That's what I understood. But how much RAM they need to keep the client? Usually it is a very expensive then though.
Yes. So SAP basically sells licensing based on one unit. So one unit is 64 GB. So
Okay.
licensing is based on say 2 units. So for example, you want to order 2 units of HANA, then you would order around 128 GB of RAM. So basically, I'll tell you how it actually very much cost performance optimized is. Now, if you see HANA, basically you have both your OLTP engine and OLAP engine. So HANA can do both OLTP, online transaction processing, and as well online analytical processing. Okay. Now, for example of OLTP system is ECC and example of OLAP is BW. Usually, before HANA came into the picture, what we used to do is we try to do all the inserts and updates on the ECC side, and we move data from ECC to HANA to BW, and then generate reports over here. So this is to have decent performance in reporting. To have a decent performance in reporting, we move data from ECC to BW. Okay, now again the issue here is the volume of data is so high, even the BW systems are unable to handle. So what SAP has done is they have bought in something called BI accelerator into the market. Again to fasten up the reporting in the BW area. But in BIA, so please see, here you are copying a set of data, here you store a set of data, and then here you store another set of data, and to move data from here to here you require a lot of effort, and then here you store one more set of data, and there is a lot of maintenance in doing performance optimization to BW. But now when the HANA came into picture, now you can do both your OLTP plus OLAP on the same DB. So this is called HANA Live. On HANA Live, you directly have your ECC system on HANA, so you don't have to data provision in case of lower volumes of data. So you have only one set of data, and then you have engines to process the data. And again, let's say you have a 250 GB of disk, or let's say you have 40 GB of disk. The same 40 of GB of disk, the same data when you store it on memory, you require only 10 GB at an average. 10 GB of RAM you require to store the same 40 GB because data in disk is not compressed, uncompressed format. So 40 plus 40 is 80, 80 plus another 20, 100 GB, and then performance optimization, moving of data, maintenance, aggregates. But now you have only 10 GB of data in memory, both OLTP, OLAP, everything can be done in HANA. Also the same data can be used for application development, like you want to export this data via HTML to, you want to publish this data in HTML via JavaScript. You can do that as well. So actually,
Yeah.
when compared to this kind of, I'm sorry to interrupt, I'm sorry, please go ahead. You're saying something.
Yeah. Sorry to disturb you. Okay. It means like it is storing in a RAM because in a compressed format so that it is going to be increase the performance.
Yeah.
That's I got it. Like the another question it is, say for example, like in a take a Walmart client only, right? Okay. Walmart is already established like ECC and BW. Okay.
Yeah.
They have it from ECC. Right now, most of the data is there already transferred from ECC to BW.
Yeah.
So that through the BI extractors, they are going to move to HANA. For example, like in a future, like they want to do it like how they do it in a real example, like after doing the HANA implementation, they want to maintain the data in a both systems, or like they in a future they directly like move from after one conversion from BW to HANA, the single time they will do the ECC to HANA online, or usually how the business scenarios it goes.
Yeah, if you see, it depends on client to client, but I'll try to explain all the scenarios. So one scenario is directly having ECC on HANA. That is very,
Okay.
very expensive. It is something like you're buying a BMW car.
Okay.
And then the other scenario is having your ECC I'll tell you the other scenario. The other scenario would look something like this. You would have ECC on MS SQL. And from MS SQL via SLT, you replicate only those tables which are required for reporting in HANA. And finally do your BOBI. This is one. This is called native reporting. You here in this case you don't have BW at all. But the other case, here you do BOBI directly. In this case directly on HANA. This is the other scenario. This is the first one. This is the second one, and this is the third one. In third one, you have ECC again on MS SQL, and BW you have on HANA. This is called BW powered by HANA. Now, why this is because already a lot of people have invested on BW. Now, BW is around for last 15 years. Now, there are more than 14,000 customers who are using BW. So, for these customers, in order to not to go the investment waste, what SAP has done is, they are given a database migration option where they can convert from a non-HANA DB to a HANA DB. So all these 40,000 customers can leverage HANA by converting the databases from an MS SQL to HANA DB. So suddenly the BW application layer is faster. But our course is not based on BW powered by HANA because this is for people who already done BW. And for this course, there is a course called in SAP Standard BW 362. Even I am a BW consultant. I have worked BW in more than 5 years in past. So this is a separate area, but here we focus on native HANA modeling because BW is an intermediate solution, and especially it's an enterprise data warehousing solution. But
like, sorry to bother you, but in a real market, if I see that like most of the jobs is coming with the BW with the HANA knowledge, right? Along with the ABAP.
Along with ABAP, is it? So, yeah, ABAP is necessary, but in order to understand the SAP systems, because people who already know ABAP, the advantage is they know in and out what is the table, how the relationships are defined between table. That is the most important for an ABAP consultant. And most of the non-SAP consultants cannot understand is, they don't understand what is VBAK, what is VBAT, what are MARA, how to, and what is MAKT. They don't understand all this. So that's where the ABAP advantage is very advantageous. But when you're using HANA, we won't use the standard ABAP reports that are generated on the ECC side, because we need to again do remodeling in HANA DB by using attribute views, analytic views, calculation views. We have to model all this, and on top of this model you have to use BOBI as your reporting tool. We don't use the ABAP application layer to do reporting. It's very static. So for presentation of data we use BOBI. For data modeling, again we do model in HANA again.
It means that BOBI is a separate, like there we never use the ABAP code,
No.
or like it's a different code.
We don't use ABAP at all in HANA. So in this area in HANA we don't use ABAP code, but yes, we use ABAP code when you want to optimize the existing SAP customers solution. ECC is now used by more than 85,000 customers, right? So all these customers you want to optimize for them, for their business process, then you can use the same ABAP. You have to tweak the ABAP code over here. But if you are working as a SAP HANA application consultant, you will not have an opportunity to work on the ABAP side. Because most of the time we work on data modeling, and HANA purely is based on model to code approach. It means that we only generate the model, system automatically generates the code for us. It's not like in ABAP code to model. Probably you'll understand more on this in the coming classes. But
okay, I got you, Rafta. I got idea. Like, no, I'm seeing what is the importance of the BW here. That's the thing. Yeah.
Yeah, very good. The importance for BW is for the existing customers because they've invested billions of dollars in this. Now, in order to, because suddenly if I say today, wipe off your BW and implement HANA, customers may not agree because we are going to disrupt their existing solution. So that is the reason SAP given an intermediate solution of having BW powered by HANA, so your application layer gets very, very faster. Alright?
Yeah.
No, for the third scenario, like where we have a BW system,
Yeah.
yeah, for the data, like data modeling and data provision, all you have to do from BW or from directly from the EPC.
Okay, there are, again here something, we have something called mixed scenario. So in mixed scenarios especially, you take the advantage of HANA and you take the advantage of BW, you do mixed modeling here. This is called as mixed modeling. And probably if you are from a BW background, I should have explained more on this. But generally in BW you have different flows like data source, DSO, info cubes, multi-providers. You have multiple layers. You have multiple layers of modeling. But now what SAP has done is, now you can go for a very simpler modeling called as LSA++, layered structure architecture. In a way, the complexity of modeling reduces very dramatically as the database is very fast in processing the data. So that is usually comes on the BW application layer. And purely this is for the BW consultant and people who have quite a really good hands-on the BW. But the focus here is on HA100, HA300, HA350 and HA900. Now this is the standard SAP, standard material that SAP provides for the native HANA modeling. It means that if you don't have BW in your landscape, something like this, still we can do a lot of reporting on HANA without having BW. This is for newer customers. For newer customers, SAP basically suggests don't have to go for BW because they have never invested on BW and they do not require enterprise data warehousing solution. So directly we would do modeling in HANA and BOBI without having BW for newer customers, and this is for older customers and this is for new implementation.
Okay.
Okay then, any other questions you can go ahead, or I'll close the session for now. Any other questions, please go ahead.
Yeah. We are good. Like just just thinking about like the concept. Okay.
Okay. Probably we'll have we'll discuss more in detail, and I would love to discuss with you all the concepts.
Yeah.
Okay.
I think we are fine with Nagarjuna. I think we are good right now. Like the level of confidence you have it's good. Okay, let's see. Like we'll talk to them, with her, and we'll finalize the things. Okay.
Okay, thank you. Have a great weekend.
Okay, you too.
Thank you, Nagar.
Your time. Thanks for your time. Okay.
Thank you.
Thank you.
Bye.
Okay. Bye.
Yeah. Thank you. Bye bye.